Here's the final part of the Plotly and Dash tutorial mini-series. I'm going to take things a step further in today's version of the code. I'm going to add support for internationalization, which is really hard to pronounce, and we're going to change the design to better separate the data from the UI components. You'll find the final version of the code on GitHub. The link is in the video's description. Now let's take a look at the code one more time. This is where we ended up in the last part. I've created a simple Dash application that has a bar chart and a pie chart and a couple of drop-downs, and I've loaded some data from a CSV file and displayed that on the chart. Now if you look at the web interface, this is what it looks like. And I can select months, I can select categories, years, and the charts are being updated automatically. So that's pretty cool. But there are a few things that are an issue in the way that it's currently set up. One issue is that all the texts are directly written inside the script. We set a year title, and in every UI component, we're basically defining these texts all over the place. Now, if you only plan to ever serve the English market, that's maybe not really an issue, but if you want to scale things up a bit and move to other countries where they might not understand English, or it might be a better experience for the user to display the dashboard in a different language, you need to think about localization and dealing with translations. Another issue with this is that it generally is helpful if we put these texts in a separate place, because you can send that to somebody who can check the spelling. You don't want them to go through all of your code to find all the titles everywhere. You want them in a single place, and then you simply load them from a file, which is much cleaner. Now, there's several ways in which you can deal with translations. One way is to do it all yourself, basically define a JSON file or YAML file, define the translations in there in some format, and then load the file here and then write a simple function that translates an ID to a certain text value. I mean, in a pinch, that will certainly work, but it's quite limited. What I'm going to use is an internationalization package called Python i18n. I18n normally stands for internationalization because that's a really long word. And this offers a lot of extras, like being able to deal with pluralization, multiple languages, multiple namespaces to group your translations, and more. So I've put the dependency in the requirements. So if you install requirements.txt from the code on GitHub, you already get this installed. So how does it work? Well, it's actually really simple to set up. So I'm going to import the library first. So that's how we do the import, and then I'm going to define the current locale. And let's say that at the moment we're going to use English. And now in the main function, the only thing that I need to do is set the locale. 18n.set. And then the locale, we're going to set it to the value of this constant. And now we can load the translation file. So I already prepared a couple of translations in the locale folder right here. I have two namespaces, general and category, and I've put these in YAML files. So there is a .nl, I'm Dutch, so I added Dutch translations as well. And there is a .en YAML file, .nl.en. And what it looks like, it's really simple. Like here, for example, this is the Dutch version. Here we have an English version, which have things like the title, month, category, anything that we'd like to translate in the application. And they also did that for the different categories. So I have car, entertainment, etc. This is the Dutch version, and I have an English version here as well. Now, the only thing I need to do in order to get started with internationalization is make sure that the library loads these files before we start the application. And for that, we need to add it to the load path, which is a list of paths. And this is what the folder is called. So now what we can do is, instead of writing the title directly in the code like this, is that we can use the translate function from the internationalization library. And what we want here is the namespace general, and we're going to use app title. And this is also what you can find back in the general file. So here we see app title is financial dashboard. So now the title is going to be translated for us. So here's the version of the application with the English title. And if I now want to change it to Dutch, I simply change the locale here. Or you could even make it interactive by adding a drop-down in the user interface and then changing the locale by calling this function. And now if I reload the application, you're going to see we get the Dutch title. So this is really neat. And now we can simply define all translations in a single place and then access them within the application by using the translate function of the internationalization library. So in the year dropdown, for example, we can do exactly the same thing. So also here, I'm going to import the internationalization package. And then instead of setting the year like this, I'm calling the translate function. And same for the select all button. So when I reload the page, now you see that the year drop-down is going to be in Dutch. I guess if you're not Dutch, the interface is now getting incrementally harder to understand for you. Sorry about that. Maybe to keep things a bit clear for you, let's switch locale back to English. So this is really nice because now by changing one value, we change the translations all over the application. Here's a version of the dashboard where I added these translations to the different drop-downs that you see here. The issue is that the values for the months, categories, and how they're being displayed in the charts are still not being translated. And doing these translations inside the charts themselves is sometimes a bit complicated because we have to modify labels. It's not always easily doable. So an alternative of what you can do is actually translate it in the data itself. But for that, we need to do some data processing after we've loaded it. If you remember what we did the last time, we created a load transaction data function that read the data from a CSV file and then did some processing here, and then it returns the data. So what we can do is add a step here to translate also the names of the months and the categories. I could simply add that code here to load transaction data, but I'm going to do something a little bit nicer by introducing a post-processing pipeline. And then what I can do at the same time is move these things also out of the load transaction data code and put it in a separate step that's going to be part of a pipeline. And it's actually pretty easy to set up. So what I'm going to do is define a type called preprocessor. And this is going to be callable. That is going to take as an input a pandas.data frame. And it's also going to return a data frame. Pandas, by the way, also has a pipeline system to do this, but I just want to show you something simple. So we have the preprocessor type that looks like this. And now what I can do is, for example, define a function, create year column. And this is going to get a data frame, and it's going to return a data frame. So it adheres to this preprocessor type. And what this is going to do, scroll down, we have the operation right here. Let me copy that over and put that in here, like so. And then this is going to be df, and then it's going to return the data frame. If you want this to be immutable, you could create first a copy of the data frame and then set the year in the copy and then return that copy. I'm just changing the data frame here to keep things simple. And similarly, what I can do is create a function that adds the month column. And here we're going to copy this line, like so. And what I should probably do is move data schema above these function definitions so they can actually access the type correctly. And this should be df. There we go. We now have our two processing functions. And now what I can do is compose these functions to create a processing pipeline. And for that, I'm going to write a helper function called compose that's going to do this job for me. And I actually did this in an earlier video series as well. If you want to check that out, click the link in the top. Now, I have a compose function that takes a sequence of functions which are of type preprocessor. And this is also going to return a preprocessor. So what this will do is combine all those functions into a sequence. And then what I'm going to do is use reduce. And reduce comes from functools. And reduce allows us to define a lambda function that takes two other functions, f and g. And then it returns another function which takes a value, let's call it x, and then creates a sequence of calling first f and then g on x. And the initial input is the list of functions that we give the compose function. So there we go. We can now use compose and supply it with the functions that need to compose as arguments. So if I go to my load transaction data, I can create the preprocessor. And that's going to be a composition of creating the year column function and creating the month column function. And now what I'm going to return is the preprocessor and then call that on the data. And now this is a nice setup because I can add any type of pre-processing function to the pipeline and do all kinds of things to prepare the data so that the dashboard can actually use it. Let's just verify that this still works, and it seems it does, so that's good news. So we were doing this in order to be able to add translation. But remember, I started working on the pipeline in order to support translating the data in either English or Dutch. So now what I can do is add extra functions that allow me to do that translation work for me. For example, what I can do is create a function that does a translation of the dates. So translate date, and that's going to get a data frame. And I also need to supply it a locale. And what I can use to do this is Babel, which I also installed as a dependency, which has a really easy mechanism for translating dates. So I'm going to import babel.dates. And then in my translate date function, I'm going to call that to translate the date. So as a first step, I'm creating a helper function that creates the translated date representation. And that gets a date, which is a datetime date. And I need to import datetime for this, like so. And this is going to return a string, and this will use babel.dates.formatDate, which will format the date for us according to a certain locale. So that needs the date. And I need to specify format. So in this case, I want to represent the month, so I'm going to use this representation, but you can make a general version of this function that also gets the format as an argument. And then I'm going to supply the locale as well. There we go. And now the only thing that I need to do is apply this translation to each of the dates. So I'm going to create a data schema.month column, and that's going to get the date column and apply the function. There we go. And now actually we don't really need this step anymore because translate date already creates the column for us. But for the moment, I'll just leave it in there. And then I can do the same thing for translating the categories. So translate category. That's going to get a data frame as well. And a locale. And actually, since I'm using I18N, in this case, I don't need to provide the locale. So just like with date translation, I'm going to define a helper function. That's going to get the category. This also returns a string. And this is going to return the I18N.t. And now I need to supply the translation value. Let me import I18N first. There we go. And what I did is I created already translations for these categories. So we have category, and then we have the name of the category, and have them both in English and in Dutch. So what I need to do in the loader is construct in the translate helper function the value that needs to be put here. So that's going to be category dot and then the name of the category. So I can use an f-string in order to do that. And now what I do is update the category column, and that's not def, that's df. And then I'm going to apply the translate function that I defined before. And then I need to return the data frame. And actually, I also need to do that for translate date. So there you go. There we have the two extra functions that I want to add to the pipeline. But now we run into an issue because, well, I can add this translate category, no problem. There we go. And now the categories are going to be translated. Actually, maybe this is nice to show as well. So when I now reload the page, you see that actually the categories are now being translated into Dutch, making it even harder for you to understand if you're not Dutch. And you see that they're also being translated here in the charts, which is really nice. But the months are not translated yet because, of course, I still have to add the translate date function. But the problem is, if I try to add that, like so, there's an issue because translate date needs a locale as a parameter, and I didn't supply that here. And there is also no easy way for me to supply that because compose expects preprocessor type functions, and translate date doesn't adhere to that type. So how do we solve that? Well, we can use functools again by relying on partial function application. So what I'm going to do is use partial to apply the locale value to translate date, and it gives me a new function that does adhere to the preprocessor type. So partial, and that's going to get translate date, and then I need to supply it with the locale. I don't have the locale here, so I need to pass it as a parameter to load transaction data, like so. And now the error is gone, and we use partial application to solve this problem, which is really neat. The only thing we need to do in the main file is add the locale to load transaction data call. So that's what I'm going to do here. And I'll add the locale argument like so. And now when I reload the page, you see that we now have the months translated as well. There's one more thing that I want to show you, because at the moment I'm not so happy with how coupled the user interface is with the data. For example, if you look at the pie chart, you see that there's like a bunch of processing happening here, doing stuff with pandas data frame, creating pie charts, and the same thing in the bar chart where we're creating a pivot table using the pivot table method from data frame. So there's a lot of detailed stuff going on here in the user interface, and I don't really like that. Because this means that if we ever change from data frames to something else, we're going to have to go through the entire application and change everything everywhere. And it's also kind of hard to find stuff because it's right in the render functions of the user interface part. And I'd like this part to focus on user interface stuff only. And that's not a new idea. Architectures like model, view, controller also provide that separation, and that's kind of what we're trying to do here as well. So we have the model, which is the data, right? This is actually the loader, the data frame. We have the view, which is this component or the other components that we built, and we have the controller, which contains the logic. And the logic is this part. So it makes sense to remove this part from the view so that the view is less dependent on things like pandas. What you can do is group all that pandas processing stuff into a class. And then instead of passing the data frame around, you pass an object of the type of that class around. So let's create a class called data source. And I'm going to use data class for this. And I'll also need pandas. Data source, that's going to be a data class, and I'm going to have one field which is a data frame. There we go. And now what I can do is create a bunch of methods that perform operations on the data or retrieve things from the data. For example, I could create a filter function, and that's going to get years. And I'm going to make that an optional, so you can also not apply the years filter. So there's a list of strings, and I can do the same thing for the months and for the categories. And I'm going to let this return a new data source so I can apply all kinds of filters in sequence. For now, just pass, and you see there's an error that data source is not defined because we're currently defining the data source class. What you can do to solve this is either put this in double quotes, but another thing you can do is from future import the annotations. And that's going to enable to use the data source type in the data source class. So what do we do here? Well, it's pretty simple. We're going to use again the query method. So filtered data, self.data.query, and then that's going to be year in years and month in months and category in categories. And then I'm going to return data source based on the filtered data. So now if I wanted to, I could call several of these filter operations in sequence. It's just a few things I need to take care of because years, month, and categories are potentially none. So that means that if years is none, we just need to make sure that we select all the years because that means there is no filter. And for that, I'm going to add a couple of properties. So the first one that I need is something that gives me all the years. which is a list of string. And that's going to return self.data schema.year. And I need to import the data schema. There we go. And this should be a list of strings, like so. And next to all the years, I'm also going to need the unique year, so I'm also going to turn that into a property. That's also a list of strings, and this is going to return a sorted set of all the years. And I'm using integers as a key so that it's sorted by year correctly. And now what I can do here is, if years is none, years equals the unique years. You can do the same thing for the months and the categories. So I've just copied that here. It's going to be exactly the same, so I won't do it in the video, but I'll put the final code in GitHub. So we have our data source. And now what's really nice is that we can go in each of the components and then we can use the data source instead of directly relying on the data frame. So here, for example, I have the year dropdown. So instead of passing the data frame, what I can do is, let's change this to be a source of type data source, like so. Let's also make that a local import. And now what I can do is, I don't need these anymore because they are easy to compute from the source. So I'll just delete them. And then in my callback, I simply return source.unique years. And same thing here for the dropdown as a value, I can return source.unique years. And here the same thing. And now, of course, I also need to update my layout to not pass the data frame, but pass a data source. So I can also change this to accept a data source, similar to what I did in the other place. And then this is going to be local import. And then for the year dropdown, I'm going to pass the source instead of the data. And you can do the same thing for the month and the category dropdown. I've already prepared this work before for the month and category dropdown. It's very similar to how it's done for the year dropdown, so I won't cover it in the video. But I do want to take a closer look at these charts and how to update these. So for now, I'm going to pass the source here as well, which is wrong because at the moment they still accept a data frame, but I'm going to update these components to accept a source. So starting with the bar chart is actually pretty complicated at the moment because it's creating a pivot table, and ideally we'd like all this processing to not be part of the bar chart, but put it in the data source. So I've copied over the create pivot table function that does this work for me. So I can simply call this function and use it in the bar chart component. So what we need to do in the bar chart is first change this to accept a data source, like so. And now we can update the code. So here I'm going to create the filtered data, which is going to be source.filter. So I'm calling the filter method now. That gets the years, months, and the categories. And then I can use create pivot table to create the pivot table that we need for the bar chart. So this, I can throw that away. Now there's only one thing here. This is not great because shape is a very pandas specific thing. So what we can do instead in source is add a method here called, for example, row count. And it's going to return an integer. And this is going to return self.data shape 0. And actually, let's turn this into a property. And now in the bar chart, I no longer need to know implementation details of my data. So what I can do is change this to if filtered source.row count. And actually, I put a not in front of that. So if there is no data, then I'm simply going to return a div. So we have the filtered source. I did this check, and now we can create the pivot table. So this, we don't need it anymore because it's part of the data source. And then here I write filtered source dot create pivot table. And I can even update the labels in order to use the translation. So we can have the category, which is going to be I18n dot, and then general dot category. And let's also do that for the amount. There we go. So this is our new bar chart component, and then I can go to my layout, and then the arrow here is also fixed. And we can do the same thing for the pie chart. Now again, the pie chart is very similar to the bar chart, so I won't cover this in detail in the video, but you can check out the code in GitHub to see what it looks like. And now the only thing I need to do in main is not pass the data directly, but use a data source. Like so. And now when I reload the page, we get the new fully translated bar chart here that also gets the translated categories, and we separated the UI aspects more from the logic. What's actually pretty nice is that we can now even use abstraction if we wanted to even further separate the things. So data schema already, that's no longer needed because data source already takes care of a lot of those things. But we could even turn the year dropdown into something that's not dependent at all directly on the data source class, because the only thing that the year dropdown is using, if you look at the code, is the unique years property. So what we could do is create a class here, and let's call that years data source. And this is a protocol class. And the protocol class has a property unique years, which is going to return a list of strings. And now instead of passing the data source here, I'm expecting a years data source, so something that has a unique years property. And what you see now is really interesting because the data.source dependency is no longer needed. So I remove this. Pandas is also not needed anymore, actually. But if I go back to my layout, actually there's no issue at all. It's perfectly fine to pass the source, even though this render function expects a year's data source. That's the power of protocol classes, that it allows you to define the interface that you expect an object to have if you pass it as a parameter, and then Python's doc typing system, the structural typing system of Python, is going to take care that this matches. And of course, for running this code, it doesn't matter at all. You get exactly the same result. But if you look at the year dropdown now, this user interface element has no direct dependency at all on the data, which is pretty cool. So I hope this video series has given you some ideas of how to set up dashboard applications like this, how to make sure that data processing and user interface elements are properly separated, and how you can use abstraction to increase that separation even more. Thanks again to Mark Todisco for helping me out with setting up this example. I hope you enjoyed this video. If you did, give it a like. Let me know in the comments what you think. If you want to see another example of an app that uses data processing and machine learning, check out this series. Thanks for watching, take care, and see you soon.